Alright, so page 12, picking this up really quickly. 350-liter fish tank. Every 2 drops for 5 liters of water, and 1 cupful is 40 drops. So, somebody, how did you set this up? Okay, Con, let's hear it.
Well, I did 350 divided by 5.
Why?
Then I was.
Why?
That's basically 1 drop.
Okay, so every 2 drops is 5 liters. So you wanted to figure out how many drops you want. Right?
And then I multiply by 2.
Okay.
To get 140.
Okay.
And then I divide it by 40 since 1 cupful would be 40 drops. And I got 3.5 cupfuls.
Good. Okay, because it's every 2 drops. So that means in total you need 140 drops. And because 1 cupful is 40, so when you divide it by 40 drops, you got that 3.5 cupful. Okay. In this case, we have a decimal. Does the decimal make sense in this case? Yes. Okay. So you would keep that decimal. Remember yesterday I was saying in the word problems, it depends on the context of the question. There's no one answer fit all. So and then notice how I set it up right here. You're dividing the same unit for unit. So I'm not dividing 350 by drops. Okay, because I'm comparing apple to bananas, not apple to apple. So how many of you got 3.5 caps? All right, good. How many of you wrote units, caps? Good. What happens if you don't write caps? Half a mark off, as you saw on your last test. Yep. But that was not the question. So you would have answered half the question. It was asking you how many caps you need. Yeah. So you would have lost a mark there if you didn't do this extra step.
What if you wrote 3 caps and 20 drops?
Oh, that's good too. Yeah, you can do not 40 drops, 3 caps and 20 drops. Right. You can do that. Okay. As long as I can see your understanding, you understand the context, that's good. Okay. One last one I wanted to go over. This one right here, page 13, for the E. Imagine there were 200 people at the wedding, and the ratio remains the same. How many people would be eating pasta, and how many will be eating soup and salad? So to set this one up, we want to set up the ratio, our proportion. Remember yesterday we went over fraction equals another fraction. That's how you want to set it up. All right, so people at the wedding and people choosing pasta. So I can write it as a ratio, people over pasta. Okay, doesn't matter if you write pasta over people or people over pasta, as long as you're consistent again. So 75 people, and 40 of them chose pasta. Now I want to know for 200 people, do I write the 200 on the top or on the bottom? Top, because it's the total people. And I want to know how many eat pasta. So see, fraction equals fraction. What's my step 2? Okay, or if we follow the cross multiply, right? Cross multiply. So I get 75x equals 8,000. Okay, and then what's my third step? Divide. All right, that 75 goes on the bottom. So our 3-step, fraction equals fraction, cross multiply, divide. And you get louder? 106. 106.66. Can you have 0.6 of a meal?
Yes.
Technically, but no. Do you think they'll charge you for 0.6 of a meal? No. All right. I don't want 100 pasta in my plate. I just want 60 pasta on my plate, so that I'll pay 2/3 of the price. Okay, it doesn't work that way. So this, I would have to round it to, what do I round this to? Melody? 107. What's my unit here? Pastas or dishes of pasta. Okay. As long as you write like something like this, I get what you mean. That is good. Okay, and then now for the soup and salad. How do I calculate that? For the soup and salad part, there was two parts to the question. I wanted to find out how many eat pasta, how many have soup and salad. So two different ways. Second way, set up the same way. So 75 over 40 equal now it, oh, sorry, not 40, 35. 75 people, 35 eat soup and salad. From here. Okay, 35 people eat soup and salad. And then I can set up the same way and do the same thing. Okay, so I can do that, set it up the same way, cross multiply, divide to get my answer. What's that? So here, this way, I should actually use y, so that it's not the same variable. But let's say I use y, not the same variable. So 200 times 35 divided by 75, I get this. So if I round it, I can say 93 soups. All right. What's an easier way to figure this out then? Think back to like the grade 4 or grade 3 method. Con? Right. How many people are there in total? 200. So if you know that 107 is having pasta, subtract that, you'll get your 93. Unless some people just want to go to the wedding and not pay for dinner, then then that's a different story. Okay. So that's how you would set it up. Some people this morning were trying to set up the ratio with all three, but then you have two different unknowns. So that's why you have to separate it into the two separate things. Okay. Any question from yesterday's homework? Okay. So let's move on to today's coding. Yeah, not yet. I'm doing my lesson. It will be short. Coding. So, for if you're wondering why are we doing coding in math class and not computer science class, I had the same question for the government. But the government decided that you guys need to do coding in math. And so we don't need to actually do coding on a computer. We're not doing that. I'm just teaching you the concept. When will you actually do coding on a computer? In computer science class. Okay? So I'm just teaching you guys the concept, tying together the idea with math. So for example, output is just when you run your program, what will the computer tell you as an answer? That's what output is. In the past, in my days, in university, we did Java. Have you guys heard of Java? Yeah. So
Only at Starbucks.
yeah, not the same type of Java, but see how outdated like this is. But so in back in the day, I actually had to type in the code, and then we have to press that F1 button to run the program, and then it won't run and says an error, and then you're like screaming at the computer screen at 4 a.m. in the morning looking at like 400 lines of coding to figure out where that mistake is. Where did I miss that period or that dot or that comma or that space? So, and it doesn't tell you where your mistake is. So nowadays, much more friendly. How many of you use Scratch? Good. Okay. How many of you use Python? Okay, so you see how like it's color coded, you just drag and drop. It even like if it doesn't work, it won't let you put that puzzle piece together. Yeah, so it's right now it's so much friendlier. Um, but is it really realistic? Not really. In the future, when you do some web page programming, you're not gonna have those color codes. So, loop. What a loop is it's like a repeat. You're telling it to keep asking the same question over and over again until a condition is met. So the condition is like your if and else. So loop is like keep repeating. And then condition is the if this happen, do this, or else do that. Okay. So let's go over an example. Those are some of the key terms you need to know. So let's go over this example right here. So suppose so right here, what you're doing at the beginning is setting your variables. So number one right here, that's called your variable. So instead of saying like let x be 17, let y be 23, you can set up your variables. You can call it apples, banana, orange, numbers. You can call it whatever you want because it's a computer. It's a computer that you type. Okay. So the beginning, what you want to do is always set up your variables. Give it a name. Give it a value. And then here is your if and else statement, my conditional statement. If number one is bigger than number two, then your output is going to be number one is bigger than number two. Right here, remember these are variables. So in your if else or in your program, these words get replaced. So in this case, which one is bigger? Number two, right? So it's going to go to the else. And at the output, it's going to say 23 is bigger than 17. It's not going to say number two and number one anymore. It's going to replace it because these are just variables. So your output in this case, your output will say 23 is bigger than 17. Okay. I've seen on tests people write me that number two is bigger than number one. I know number two is bigger than number one, but I need to see that those are just placeholders. They represent a number.
So you can give it a name, right?
Yeah. So any name you can say Sarah and Con or something. Sarah is bigger than Con. Okay. So this next example, same thing. You can have these ask. All right. So the computer could ask you, what is the first number? So Ethan, give me a number.
20. 67.
67. Good number. All right. And Melody, give me a second number. 2. Okay. Which part is it going to go to? The first part or the second part? First part or second part? Okay. Who says first part? Right. Because we know 67 is bigger than 2. So it's going to go through the first part. Okay. And so once it goes to here, it's not going to go here anymore. It knows to stop here and give the output. So what would my output be in this case? Misha?
Yeah, I would say number. No, sorry. 2.
Right. Thank you. See, I'm pointing out the common mistake people do. Okay. Nice and easy. So let's try a harder example. Oh, question. Sorry.
This one, can we do a greater than symbol instead of writing is bigger than?
this one is, you have to say what it says actually. So if this is your output, you have to make sure your output is exactly word for word. Even if there's a comma, if there's a period, it gets translated right over. Yeah, so like the capital and stuff like that too. Number 2, calculate the average of points scored at a volleyball game for the season. So first, the computer is going to ask you, how many games did you play? All right, so let's say we played 5 games. So the computer asks you, I'm going to say 5. Okay, what's happening right here? What does this line mean right here? Set total score equals 0. What's the purpose of this line? Yeah.
To reset like the variable, like in case the code has been run before.
Good. Okay, so you're setting up your variable. This is your variable, and you're giving it an initial value, almost like you're resetting your variable. Good. Okay, and then the repeat. This is your loop. So the repeat, which is your loop. How many times am I looping this? How many times? Okay, so it's gonna ask you what was the score. How many times am I gonna ask you what was the score? Yeah. Catherine? 5 times. Because this is also your variable. You set variable of total games to 5, so that's how your computer knows to run it 5 times. So let's give it some score. Adrina, give me a number. Under 21. Under 21. Less than 21. 16. Okay. Dina, give me a number. Less than 21. 16. Okay. Grace, give me a number.
4.
Whoa, they lost badly in this one. Eliza, give me a number. Yeah, a number less than 21. Whoa, they lost badly again. They're losing confidence. And then who's been quiet? Kazea, a number less than 21? 11. Okay, they gained back a little bit of confidence. But how many of you play volleyball? Volleyball. Nobody play volleyball? What's the score to win a set? 21. So nobody won. So they lost all 5 sets. That's very sad. Yeah. So every time, what's happening in this? So they ask you for your score, and then they're gonna add that score to the total. So they did 0 plus 16, and then loop 16 plus 16, loop 32 plus 4, loop 36 plus 5, loop 41, 41 plus 11, 55, no, 40, 52, 52. So, and then here it's going to do the math for you. I know you guys have calculators, but you're trying to do a program so that the computer does the math. So set average, another variable right here. Total score, if I did my math correctly, was 52, divided by what? Which is 5. So 52 divided by 5. What's the output going to say? Sarah? Nope. That's not the output. Nope. That's not the output. What is the output? If I press F1 to run the program at the end, what's going to be displayed? Ethan?
The average score was 10.4.
The average score was 10.4. Good. Okay. Remember the output. You see the quotation marks right here? That's the exact wording that's going to be displayed. Okay. So your output in this case is the average score was 10.4. If you just write on the test for me, 10.4, nope, that wasn't a part of the program. All right. You knew the answer because you knew the math. not because of coding. And on the test, I'm testing you guys on the coding part, not if you know how to add and divide. Okay. Last one. Determine the unit cost if you purchase 12 chocolate bars for 1860. So unit rate. So you see why this lesson is in this chapter, because we're tying it in with unit rates. So first we create our variable, total cost. That's our variable, and we set it to 18.6. We set the unit, total unit, our second variable, to 12. And then we're going to set unit cost equals total cost divided by unit cost. So what is my output? Who can give me my answer? What is my output? Run it like again, let's say this is my computer. I spent like the whole night programming this. And I press F1 to run the program. What should I see as my output if it runs? Let's see who has been quiet. Cheyenne?
Yes.
Yeah, what would my output be?
Well, like for number 1, or
This one, number 3, example 3.
So yeah, the output would be the unit cost. So it would be 18.6 divided by 12.
Is that my output? No.
No, like if I do it on the calculator, the output that comes out, that would be the output.
All right. So again, I'm not testing you guys on your calculator skills. I'm testing you guys on your coding understanding. Yeah. Right. The unit cost is $1.55. Do I need the dollar sign here? No, good job. Probably the only time where you're not going to lose marks with the unit. Why am I not adding it in a unit? Melody?
Because there's no units setting a variable.
Right. If in my statement right here I had a dollar sign, then yes, you need that. Otherwise, this is your output and you're displaying exactly just this. Okay? So again, I'm testing you guys on your understanding of the coding, not if you know how to add and subtract and divide. So on the test, there's going to be similar questions like these where what is my output? What is the purpose of this line? What is that if else statement? What does a loop do? How many times is this loop going to happen for? And so forth. Okay, so these comprehension questions. If you put in these into a computer program, it's never going to run. Okay. And so that I'm going to leave it for the computer science teacher to teach you guys how to write the proper language. All right. So for the rest of the class, you're just doing these ones. So number 1 and number 2, 3, 4, 5, 6 on the next page. Notice right here, I do have answers right here. These answers is because I know coding is like something new to you guys. It's like you're not the most comfortable with. That's why I gave you guys the answers so you can refer to it, know at least that you're on the right track. So it's only this for homework. That's all. Tomorrow we do the review. We're done this chapter. When is the test again? We could write it Monday. Checked. We could write it Friday as well. But official date? I thought we voted on Tuesday. Okay, so if you are ever unsure, where can you check for the test date? Brightspace, because we don't have a Google Classroom. Brightspace is so much better. So 23rd, Tuesday, next Tuesday, a few days from now.